Hi, in this video we're going to do a little bit of differentiation of a trig function using the chain rule. We're going to put it equal to 0, the differential equal to 0, and then find a trig equation and solve it. So this is about making links between two different parts of the course. So a curve is given by the equation y is equal to sine of pi cos x. Find the coordinates of all the points on the curve for which dy by dx is equal to 0 and x is between 0 and pi. Note it says coordinates. So we've got to take our function. Y is sine of pi cos x. If we differentiate this, we have to use the chain rule. So we differentiate this bit, and then we have to differentiate the bracket using the chain rule. So dy by dx of sine is cos, so cos of pi cos x. And now we have to differentiate the bracket. So if we differentiate cos, we get minus sine. So we're going to have minus pi sine x. We now require dy by dx equal to 0. So we put cos pi cos x times minus pi sine x equal to 0. Right, if we draw the graph of sine and cos x between 0 and pi, that might help us. So there's a graph of cos, you should know these, and that's the graph of sine. We're interested where these are equal to 0. So if this is equal to 0, either cos pi cos x is equal to 0. So we want cos, this bit in the bracket here, to be equal to pi by 2, or it can be equal to minus pi by 2 as well if you extend it backwards. So we just repeat, we want pi cos x here to be equal to pi by 2. So what value of x, because we require x to be plus or minus a half, so what value of x? Well, we know that, sorry, because cos of plus or minus pi by 2 is equal to 0. So if we take x as pi by 3, because we know that cos of pi by 3 is equal to a half, because we've learnt the table, then if we put that into here, just look at it, we get cos brackets pi cos pi by 3. Cos of pi by 3 is a half, so we've got cos of pi by 2, which is equal to 0, which is what we want. We want this to be equal to 0. However, you need to consider the other one in the boundary, pi minus pi by 3. There's another one over here, which gives you 2 pi by 3. And then if you do cos of 2 pi by 3, it gives you cos pi of minus a half minus a pi over 2, and if you continue cos backwards here, then you can see that's also equal to 0 at minus pi by 2. So therefore that's another solution. Or this part is equal to 0, minus pi sine 0 x is equal to 0, so that's going to be 0 or pi. Right, so we got the x coordinate, we need to find the y coordinates now of each one. So we require the coordinates. So when x is equal to 0, we'll substitute it back into the original function. Y is equal to sine pi cos of 0. Cos of 0 is 1, and sine of pi is equal to 0. So it gives 0, 0. When x is pi by 3, we're going to get y is sine of pi cos pi by 3. So we're going to get sine of pi by 2, because cos pi by 3 is a half. So sine of pi by 2 is equal to 1. So that gives pi by 3, 1. And when x is equal to 2 pi by 3, we're going to get that y is sine of pi times cos 2 pi by 3. Now cos of 2 pi by 3 is equal to minus a half. So we're going to have now sine of minus 1 half. Minus a half of pi, or pi minus pi by 2, which gives me minus 1, and then negative 2 pi by 3 minus 1, and finally when x is equal to pi, we're going to have that cos of pi cos pi, and the cos of pi is equal to minus 1, so we have sine of minus pi, and sine of minus pi is equal to 0. So we're going to get pi comma 0. So the coordinates are going to be 0, 0, pi by 3, comma 1, 2 pi by 3, comma minus 1, and pi, comma 0. are the 4 answers to this problem. So this is a late question on the IB exam, and therefore you're going to be expected to make links between different bits of the course. I hope you've understood, and I thank you very much for watching.